All right, calculus guys, let's look at these integrals that involve trig functions raised to powers. When I'm doing these, I like to use just the table of integrals. And the table of integrals in our course, if you go a few pages in, you'll come to the trig forms. And these have the sine, cosines to the n powers. And if you scroll down a little further, actually it's on the next page, that you'll see tangent to the nth power. Okay, so let's go back through here and grab number 67 from our table of integrals that applies to this one, and it is sine n. All right, so that means it can be basically anything. So we have n equal to 3 here. So what you can see, just grab it, and also a is the number that's being multiplied by x. This is technically inside the sine function. And you can see here a is equal to 1. So n is equal to 3, a is equal to 1, and we can start plugging directly into this. So the first thing I see is a negative sign. N minus 1, again, n is 3, so that's going to be a sine squared. Ax, again, a is 1, so n is, just sine squared x. And then cosine ax, cosine of x. All right, and then divided by n times a. N is 3, a is 1, so that's just a 3. All right, plus now n minus 1 over n, again, that's going to be 3 minus 1 over 3, so that's 2/3 the integral. And this has an integral within it, you know, like kind of like integration by parts. And this integral, just like with integration by parts, ideally integration by parts, is simpler than the previous one. N minus 2 is 3 minus 2, that's just sine. So there's that formula, and now I just integrate the sine function to finish it off. All right, the integral of sine is negative cosine x, and then add the plus. All right, here is another one, very similar. It's just tangent this time. So n is equal to 5, a is equal to 1. All right, notice we're subtracting 1, so that's going to be tangent 4x. A is 1, again, n minus 1 is 4. So tangent 4th over 4 minus the integral, and notice here what we got, n minus 2. n minus 2 is tangent cubed x dx. All right, well, now we start back over, and now n is just equal to 3. So now this integral can be replaced with, remember, n is 3. We're using the formula again. So tangent 3 minus 1 is 2, tangent squared x, 1 over 3 minus 1, that's squared. All right, and now it's minus the integral of tangent to the third minus 2 would be tangent x dx. Okay, now that is following the minus sign that we started with, so we'll actually end up adding this integral when we distribute it through. Now when you integrate tangent, you typically switch it to sine x over cosine x. You let u be cosine. So du is equal to negative sine x dx. And so you do this with a logarithm. But this is also one of the integrals. It's 1 over a log, the integral of tangent is 1 over a log secant. So this is 1 over 1, because a is equal to 1, times the natural log of absolute value, the secant function. Now, you could also write this as cosine and make it a positive, but if you're using the formula, you just keep it as secant. So there is our integral, and 100% using the tables. All right, and then what about if it's a definite integral? Well, just basically anytime that you see something that has an integral in the symbol, you're going to keep the definite integral limits on it. Anything that does not have an integral in the symbol, it's ready to be evaluated at the limits. So here's the formula that works for cosine. What I'm saying is this is no longer in the integral. So that I would evaluate here at pi over 14 and 0. Okay, so anything that's out of the integration symbols, there's an integration symbol. So there I'll keep the limits integration, but anything that's not is ready to be evaluated. All right, so n is equal to 5. A this time is not 1, is equal to 7, and we got this extra 5 out here, okay? So keep that in mind as we go through here. We're going to have this extra 5 going on the outside. All right, and all the stuff that's on the inside here is the form of our integral in the table. So now that's what we're multiplying by 5 at the end. All right, n minus 1 is going to be 4, 7x sine of 7x over n times a. A is 7, n is 5, so it's a 35 on the bottom there. N minus 1 is 4, n is 5. Right, the integral of cosine Again, n is 5, so n minus 2 is going to be 3 cosine cubed of 7x dx. Okay, now this is a definite integral, so we're going from 0 to pi over 14. This one is ready to be evaluated, pi over 14 and 0. That's what I mean by we just keep on going until we get this integral that's ready to be done. All right, again, now applying this to cosine cubed, n would be 3 and a would be 7. So n is 3, a is 7. All right, 3 times 7 is 21 now. Now we have a 2/3. The integral of 3 minus 2 is cosine to the first 7x. All right, again, that integral we can do. We don't need any more tables. We can evaluate that integral. All right, this part, again, we got a pi over 14. We got a 0, 0, pi over 14. It is a definite integral, so we got to remember to do that part. I'm going to do it all in one step at the end, just so you can see it's all very similar because of the sines and cosines of pi over 2 that are going to show up. All right, and then the integral of cosine of 7x is 1/7 sine of 7x. Again, we're going pi over 14 down to 0. All right, when we plug in pi over 14 into this, so the cosine of 7 times pi over 14 is always going to be the cosine of pi over 2, and the cosine of pi over 2 is 0. The sine of 7 times pi over 14 is the sine of pi over 2, and the sine of pi over 2 is 1. So anything that has a cosine is going to be 0. That's going to be 0. That's going to be 0. Anything that has a sine of pi over 2, however, that's going to be 1. All right, but because we're multiplying here, this whole thing is going to go to 0. This whole thing is going to go to 0. So it's all going to come from this term. But be very careful here because we got a 2/3 times a 1/7. That's 2 over 21. And by the way, 0 going in there is going to make the sign of 0. So it's just the pi over 14 going in. That's all that's going to show up here. So that's 2 over 21. Okay? But that's being multiplied by 4/5. And that 4/5 is being multiplied by 5. So that's going to cancel as my final value here. By the way, Desmos will do this for you, but you have to put cosine of 7x in parentheses and then do it to the 5th power, just so you can see it doesn't understand. If you click on the little button, it says only cosine squared and inverse are supported. So you can't do it that way. So you have to take away the 5 there and then put it in the parentheses and then raise it to the 5th power, and it will understand it. All right, that button right there changes into a fraction. All right, so we can see 8/21 is the same thing that Desmos is getting.